Good morning, everyone.
Good morning.
Good morning. Uh, just ensure me that my screen is visible.
Yes, ma'am, it is visible.
All right. So today we will see some more problem based on turbojet, and we will solve some problem on turbofan based on application based. Okay. So and we will also discuss that what type of questions can come from propulsion, and we will see some connectivity with the propulsion and some bit of flight mechanics.
Ma'am,
Yes.
ma'am, those answer, ma'am.
Sorry.
Assignment questions answer, ma'am.
Okay. I will share in the portal itself. Okay.
Okay,
I will the solution I will give in the portal.
okay, ma'am.
All right. All right. So before getting started, I request all of you to mute yourself until I ask anything. Okay, because the session is getting recorded. So in future, when you will refer, right, there will be lot much of interruptions. So for avoiding that, kindly mute yourself. Once I ask anything, so unmute, you speak, and then again you mute yourself. Fine. So we will just start with an kind of brushing up with a simple problem on turbojet. So let's read the problem. A turbojet engine is powering a fighter airplane. Its cruise altitude and Mach number are 10 km and 0.8 respectively. The exhaust gases leave the nozzle at a speed of 570 meter per second and pressure of 0.67 bar. The exhaust nozzle is characterized by the ratio so and so is given. The fuel to air ratio is 0.02. These are the following two parameters are required to find. One is a specific thrust and the propulsive efficiency, and they have given that at 10 km altitude what is the ambient temperature and ambient pressure. Okay, they have given this following data. Now from here, see what are the things we have to find. So whatever they are asking you to find out, first and foremost step will be to note down the formula. So in your exam they might not mention you what is specific thrust. So from here you can come to a conclusion that what is specific thrust, isn't it? So if you know the general formula of your thrust, okay, what is a general formula of your thrust? Mass flow rate VE minus VI, then PE minus PA into AE. This is a general formula. Now one thing you have to understand here, as they have given M dot A. What is that mean, M dot A? They have discussed about M dot A, and they have also given fuel to air ratio. So this is a very important thing to understand. That means they have given M dot F by M dot A. That is given. Now if they have given the fuel ratio, then we can change or modify this general thrust equation into, if, again I am telling, if F value is given, if F value is F means fuel to air ratio is given, then your general formula becomes M dot of A 1 plus F VE minus VI plus the pressure thrust remains the same. Okay, now they have given here is a specific thrust of T by m dot A. So just divide the entire equation, both the left hand side and the right hand side, by m dot of A. So what will you get? T by m dot of A equals to 1 plus of F VE minus VI plus PE minus PA AE by m dot of A. These are the things are provided. Now you check into the question, what are the given data? What are the given data? They have given some ambient pressure and temperature. So you know this value, what is a PA is known. They have given the exhaust gas leaving the velocity. So VE is also known, and they have given the pressure. This is also known, exit pressure. So this is PE, PA is given. Now then they have also given AE by m dot of A. So this complete parameter is also given. F value is given. Now to find out this specific thrust, how can you use this? How can you find out this? VI is not there. Can you find VI? Is it given? Is it provided to you? No. How can you
M
find?
is equal to V by A. Mach number is equal to V by A. From that we can find VI.
Mach number equals to VI by A. Now how can I find A?
Root over gamma RT.
Root over gamma RT. Okay. Well, so the Mach number is given here. Okay, Mach number is given. And what is gamma? Gamma we'll consider as an adiabatic index 1.4. R is 287. And what about K? T. What about T? Which T we should include?
TA, ma'am.
TA. As we are finding the inlet, we'll use the ambient temperature. So using that, TA is 223.3 Kelvin. So you will know what is A, you know what is M, so you can find V, VI, isn't it? Find out and tell me what is VI first. First find out what is VI.
Ma'am, 239.62 meter per second.
239.62
62
meter per
meter per
second. Now you got what is a VI. Now substitute each and everything and you will get the answer. Now one more thing, you might miss one parameter. Here the pressure is provided in terms of bar. So you need to convert that bar into Pascal. So unit conversion also is also very important. Okay. So 1 bar equals to how much Pascal? 10 power?
10 power 5.
10 power 5. Fine. So ensure that you are multiplying this 10 power 5. Otherwise you will get a different answer. Now tell me the answer. Tell me the answer. Round off integers. And unit should be Newton second per kg. ensure the I need the unit in terms of Newton second per kg and tell me what is this answer.
Ma'am, is it 580?
580. Okay. Any other answer?
Ma'am, I am getting it as 585.
This is the right answer as per my calculation which I made here. It's 585. Okay. So ensure that you are getting the answer as 585 or close to that. Okay. Now we will find the next one. What we have is a propulsive efficiency. Now you know that propulsive efficiency which I have provided to you, that twice of by 1 plus VE by VI. That is the formula which I have provided. But here we are not going to use that formula, and you should not use if in case they have given fuel to air ratio. Okay, if such kind of problems they ask and they ask you what is the propulsive efficiency, you should not use the simple formula. This is actually the general formula. Okay, simplified form. Now here what we have to do, we need to include this fuel to air. So if in case it is given, you must use this formula. As fuel to air ratio is given, so propulsive efficiency twice of T by m dot A into VI twice of T by m dot A into VI plus 1 plus F VE minus VI whole square. Please understand, this is very important. Okay, this is very important to understand. If they have provided this all those parameter, then you have to follow this step. Now solve this, substitute all the values, solve it and give me the answer in one decimal place. give me the answer in percentage and mention with a 1 decimal place.
Ma'am, 71.5.
Let me check. Okay. Any other answer? So answer ranges between 71.0 to 72.0, and if it lies within this, then you have done it successfully. Okay. Now you can give a check that if you are using without this 1 plus f, are you getting the same answer or not? You can just check that. Obviously you will not get the same. Okay. So I hope all of you have done this. So once you say yes, I can switch to the next problem.
Yes, ma'am.
Okay. Now let's get into some twisted and you can say some kind of practical based question. Okay. Right. So they have said the name of the aircraft, Boeing 747 aircraft, is powered by 4 CF6 turbofan engine. So the main focus here is the what engine they are using, and what that is very important. They are using turbofan engine and manufactured by GE company and so and so. Now each engine, okay, each engine has the following data: thrust force, that is thrust they have provided, air mass flow rate, that is m dot a is given, bypass ratio they have given 5, then fuel mass flow rate, that is m dot f is given, fine, then operating Mach number is given, altitude they have given. So based on the altitude, their ambient pressure and temperature is also given, and CV value, that is a fuel heating value. Okay, they can give different name: calorific value, fuel heating value, all are same. Basically it is a CV value, so and so parameter is given. If the thrust generated from the fan is 75% of the total thrust, okay, determine so that jet velocity of a cold air and hot air, then specific thrust, then TSFC, propulsive efficiency, thermal efficiency and overall efficiency. Now first and foremost thing, you note down the parameters.
Ma'am, in previous question, F value is, ma'am, please come. F value, what F value?
F value is 0.02. Okay, can I switch?
Yeah, yes, ma'am, yes, ma'am. I confirm that.
Okay. Now let me discuss a very significant point over here. As we are doing turbofan, there can be lot many possible questions that can come from this turbofan engine. So let me first, before I explain about turbofan, someone, you can take an initiative and discuss what is turbofan and what you know about it. What you know about it? How the turbofan is different from the turbojet, you can say.
मैम इन टर्बोफैन इन मैम प्रोपेलर बेस होता है, उसमें मैम प्रोपेलर यूज होता है।
प्रोपेलर यूज होता है टर्बोफैन में? कहाँ पे?
यस मैम एट इनलेट मैम।
एट एन इनलेट टर्बोफैन कहाँ पे यूज होता है? I am talking about the difference between turbofan and turbojet. If I make a simple sketch, so compressor is driving through, here it is a turbine, then we have the combustion chamber, okay, combustion chamber, then nozzle, then inlet. This is the basic things that we see in turbojet. But how we can distinguish turbojet with turbofan?
Well, there will be a fan which is mounted in that intake section.
There will be a fan will be mounted in the intake section, okay, and
which is used to suck the air and then it will also provide some extra thrust, ma'am.
extra thrust. How? Because of putting the fan it is creating extra thrust?
Yes, ma'am.
Okay. So as any aircraft, if I'm putting additional fan, it will create extra thrust. Because of the fan? How the fan and the thrust are related? So there will be the fan, if the fan is attached, there will be outer cowling will be there. So just a second. A fan is something like this, okay. The radius of the fan is there and there is a outer cowling, okay. So additional mass flow rate is there. So once the purpose is to serve the purpose for cooling, okay, at the same time some part of air is going inside and expelling outside. So we have the large amount of mass flow rate. So that makes the turbofan very unique. And can you tell me where we can see this turbofan, where it is mostly used?
Military cargo aircraft.
It is military cargo aircraft, even commercial passenger aircraft. We preferably choose turbofan. Now when there is a turbofan, that means the core, the main core and the secondary core, there will be some difference, right? So what will be the amount of mass flow rate in the outer side and the inner side? So all these things play a very vital role. So from here only, for this turbofan, we have a bypass ratio, okay. We have the bypass ratio, and larger the fan diameter, larger the fan dia, better is the fuel, the bypass, higher the bypass ratio. And again, if the bypass ratio is again high, so it can helps a better mixing of air and fuel ratio. So that means combustion is better. So as the combustion is better, it reduces SFC, and obviously which will improve the efficiency. Can you connect all together? Can you follow this relation? Can you follow?
Yes, ma'am.
Yes. So most of the commercial aircrafts, they intend to increase the bypass ratio, and this bypass ratio again obviously depends on where to be used, like depending on the speed. Now if I talk about some speed range within 0.8 to 0.9 or 0.7 to 0.9, then obviously this high bypass ratio is going to be a very very economic in the sense of producing improving the efficiency. But if I gradually increase the speed, maybe 0.2, or I am going more than 0.999 to 0.12 or something like that, so that time high bypass ratio is may not be the very economic or provide a very good efficiency. So again this requirement is a very dependent factor with the speed. So whether it is going to provide a very economic based on the which speed it is flying. Okay, these are the basic layouts about the turbo fan engine. Now what is the formula for bypass ratio? So remember the formula for bypass ratio. It is a ratio between the air passes through bypass duct, okay, to the air passing through the core. Okay, so moreover we can call as a m dot of a secondary or the m dot of the core. Okay, that means outer cowling, if it is going around 10 kg per second and inside they are taking as 1, so the bypass ratio become 10:1. Follow? Okay, now what will be the total mass flow rate then? Obviously of the secondary plus the mass flow rate of the core. This will be the total mass flow rate. And here the formula of the thrust will also be varying, because here we have another thrust is producing by the fan. Okay, so the total thrust can be defined as thrust because of the fan and the thrust produced by the core. Okay, then now I hope you got the idea what are the values that they have provided over here. Okay, I hope now it is clear. What are the values that they have provided? Now can you tell me the given data right now? Can you tell me the given data? Am I audible?
Yes, ma'am.
Okay. Now
Yes, ma'am, you're audible.
okay, now tell me the given data. So this is a complete thrust, isn't it? Thrust is given. And what they have given, if the thrust generated by the fan, that means total is given. Out of total, 75 produced only from the fan alone. So I will know that what is the percentage of this they have used. Fan, how much amount of thrust produced by this fan. Okay. Have you noted down the values? So thrust is given, total thrust, this air mass flow rate. So what is this? This is a m dot or m second or mc. What is it? What is this m dot?
M dot, ma'am.
Huh? M dot.
M secondary plus M core.
Very good. So they have given the total air mass, that is 125 kg per second. Bypass ratio. Fuel, it's clear. It's very easy to know that. Then operating Mach number, m is given, altitude TA, PA and CV. Okay. Now first and foremost, it is very important to find this values. What is the mass flow rate of unique thing? Okay. Now let's get started. So we know that m dot equals to m dot of secondary plus m dot of your core. Now in some book you can also find that in this turbine, okay, the bypass section they are telling as a secondary and the inside one is a core. Or in another book you can also find, there are a lot many, based on the authors this kind of notations get changed. So whatever the textbook you are following, ensure that sometimes the outer section is called as a cold section, inside section is known as a hot section. Okay. So even there can be some problem, they have given the hot section and the cold section. So inside core is the hot section, the outer, the bypass part is called as a cold section. So you can also write here likewise, this is a cold section plus hot section. Any of the convention you can follow. Okay. Now they have given mass flow rate is 125. You don't know this. They have given bypass ratio. What is the meaning of bypass ratio? I have said secondary by core. So bypass ratio is also given as 5, right? So can you write like this, m dot of secondary equals to 5 times of core, sorry, m dot of core, right? Now substitute this in the over here. So 125 equals to 5 times of m dot of core plus m dot of core. So can you get m dot of core equals to 125 by 6? Can you find out what is the value and tell me? And similarly you can also find, once you find out what is a core, m dot of secondary, what is m dot of secondary, and 5 times of that. Tell me the answer one by one.
M core is equal to 20.83.
Core equals to
20.83.
okay. What about the other one? Now substitute this over here and multiply into 5.
One 104.15. M secondary is equal to 104.15.
Fine. So all of you are getting the same answer?
Yes, ma'am.
Okay. Now next thing what we'll see is they have given if the thrust generated from the fan is 7%, okay, 75% of the total thrust. So we can also find out the thrust of a fan. Can we find out the thrust of a fan?
Yes, ma'am.
How? 0.75 into thrust, right? What is the total thrust they have given? 24. So 0.75 into 24, you will get that much amount of kilonewton, because they have given in terms of kilonewton. So once you can find this
18.
18, very good. Now can you find the thrust of a core? Thrust of a core. 24 minus 18.
6.
6 kilonewton. Why I am minusing? The reason behind, because the total thrust is equal to fan plus core. Thrust of a core. Now we got some parameters in our hand. Now let's check that what they asked to find. They asked to find that jet velocity of a cold air and the hot gases. Okay, that means VE we have to find. That is, if this is an engine, okay, this is an engine. So what is the amount of VE from the core is coming out, and what is the amount of VE coming out from the secondary, or from the cold section or the hot section. Okay. So to find out this, we need to find out first what is a flight speed. We need to find out what is a flight speed. Now how can you find the flight speed? Do we have flight speed here?
Operating Mach number is given. From that we can equate it to m is equal to v by a, and from that we can find the
Very good.
velocity.
Very good. Okay. Now to find out for both, for the fan and this, first you need to find out what is the flight speed. Okay, So you can use simply m into root over of gamma r T. So T will use ambient temperature. Mach number they have given as 0.8, gamma is 1.4, R is 287, TA, and this is 0.8, and whatever it is given you write down and tell me what is the answer.
Ma'am, 239.5 meter per second.
2 239.5 meter per second. Now remember the formula for the thrust of a fan is m dot of, as you are finding for that, okay, thrust of a fan, so you have to use the mass flow rate of the secondary or the bypass, anything you can consider, secondary, and VE of fan, okay, the fan or the secondary, so fan minus flight velocity. So this is a general formula for your thrust of a fan. Now you have this value m dot of the secondary, this is at 104.15. You have VI. Now VE is need to find out of fan, and T of fan is also known 18. So you have this value, so you can find out what is a VE of a fan in terms of meter per second. And tell me the answer. Round of integers. Tell me the answer in terms of round of integers.
And 412 meter per second.
Right. 412. Now, what is the formula for core? Core means before for the turbojet, what are the formula we have used? That will we are going to use the same formula. Okay, mass flow rate VE minus VI. Now, one thing before using this, remember the given data. They have given fuel mass flow rate. They have given fuel mass flow rate. Okay, I am highlighting that fuel mass flow rate. That means, can you use this formula? No. So there is some kind of fuel value is given. So you need to use this formula instead. So m dot of A core. Okay, core 1 plus F VE of core minus VI. Is it clear? Now how can you find F? What is F? Mass flow rate of a fuel?
Mass flow rate of a fuel? MF by MA, ma'am.
MA. But which one are you going to?
Which one are you going to? MA core, ma'am.
Very good.
Very good.
So substitute that. Substitute, you know VI, you know this, you know this. From here, you're going to find out F from here. and VE core you can find out. And here also you have to answer in round off to integers. What is the value of F? Fuel to air ratio? Are you getting something like this? What's his answer? You're taking a lot much of time. Give me the answer, round off to integers.
Given is mass flow rate of fuel, no man.
This one?
Mass flow rate of fuel, man.
Mass flow rate of fuel they have given here 0.75.
Okay.
See, there is another alternative way that you can follow. Instead of finding F, you can also use m dot core plus m dot of F VE core minus m dot of core VI. You can also use this formula. Okay, instead of finding F, you can also use this formula.
Ma'am, is it 231 meters per second?
230? No,
Yes.
no. Kindly check. One thing, ensure it. when you're substituting, this is 6 kilonewton. Okay, you have to convert in terms of Newton.
Then 509.
Very good. Okay, the answer is 509. Now what did you learn from this particular question? So this complete question, we have not even completed the complete solving the this entire problem, but in the first question you learned what is bypass ratio, you have learned what is a secondary or the bypass mass flow rate, what is a core mass flow rate, how you can find the bypass ratio, how you can find the thrust of a fan, how you can find the thrust of a core, and what is the total thrust of a turbofan, and if they are some of the unknown parameter, how you can find out the unknown parameter from these equations. Okay, even see here they have given F. So when you are finding the F value, you have used mass flow rate of the fuel and the core, whether to use core or whether to use the total mass flow rate. Okay, so from this particular first section of this question you came to know this part. Now let's see what is the second part we have to find. Specific thrust. Okay, now moving for the specific thrust, how you can find that? Specific thrust.
My thrust by mass flow rate of air. No?
Thrust by mass flow rate of air.
Air.
Okay, now what is this air? Which value? For core, for your for secondary or the bypass, which value will you substitute?
Total, ma'am, total.
Absolutely. So total is 125 and here is 24 kilonewton. So you will get in Newton per this. Okay. Tell me what is the answer?
Ma'am, 192 Newton second per kg.
Okay, 192 Newton second per kg. Okay, now if they ask you find the answer in terms of meter per second. Tell me the answer in terms of meter per second. What will be your answer? So if they say the specific thrust value should be meter per second.
Same answer, ma'am.
Same answer.
Yes, ma'am. If you convert Newton into kg meter per
Yes,
second
ma'am.
square, then
Same.
I didn't get it.
ma'am, if we convert Newton into, Newton means kg meter per second square, no, ma'am. Then if units are cancelled, then at the end we'll get meter per second.
Okay. Very good. Then what is the next thing we have to find? We have to find SFC. Right. So SFC formula already we have seen. What is SFC formula? So what is SFC formula? Anyone? Mass flow rate of fuel by thrust. So mass flow rate 0.75 by thrust is 24 into 10 power 3. Okay. Tell me the answer. Are you getting this answer?
Yes, ma'am.
Fine. Now we have done this two are the very easy part. Now we will see the most typical part of this remaining section: propulsive efficiency, thermal efficiency and overall efficiency we have to find for the turbofan. Now you have to ensure when they are asking such type of efficiency for which engine they are asking. Okay, so if they have given the bypass ratio and all those things, then we are not going to use the same formula as we have discussed before. The formula are going to get changed. So you have to remember this lengthy formula. Just let me look into the formula. Okay, here's the formula. Here's a total thrust into VI. Okay, then m dot core 1 by 2 half into m by core. We have 1 plus f VE core square minus VI square plus again 1 by 2 m dot of secondary VE secondary or fan minus VI. So this is the formula. Okay, you have to remember this. So you can remember in this way also. As here both we have half instead of writing in a complicated way. So twice of This is a formula, and you have each and every parameter with you, so you need to substitute and get the answer. Similarly, for thermal efficiency, VE core square minus VI square plus in dot secondary VE secondary square minus VI square of twice of m dot fuel into CV. Okay, CV is the calorific value. So when they're asking for turbofan, this is a general formula. You have to use this, and to find out the overall, so eta propulsive into eta thermal, multiply these two, you will get the answer is overall percentage. Please solve and tell me the answer in 1 decimal place. I need answer in 1 decimal place.
Ma'am, eta propulsion is equal to 71.4%.
71.4.
Yes, ma'am.
Okay, good.
Ma'am, zeta thermal is equal to 25.1%.
21.
5.1. 25.1.
Okay. All right. Good.
Ma'am, overall is equal to 17.9.
Very good. So this is the right answer. So again, let me give you the recap. Okay. So they have given some certain parameters. What are the main important things that you learn? That is a bypass ratio. Now, one thing always you have to remember: units. Always you have to take care of that. And they in the question they might not give you a very clear statement. So from there you have to identify, as here we have seen whether they have given the total mass flow rate they have given, or they have given the for the fuel or for core. Okay, so these things you have to be clear by reading the statement. Then always you have to remember this formula for fan. Okay, don't get confused with that. Fan, and for core, what is the total thrust? It's a combination of fan and core. And if the VI is not given, they might have given you the M. Okay, now sometimes it can come in such kind of circumstance also. They have not given they can say ambient temperature. Okay, they might not have given you the what is the temperature. In that case, what will you do? Then in that case you have to take the ambient temperature 15 degrees centigrade. Okay, 15 degrees centigrade. So taking that consideration, you have to find out those parameter. Okay, so if they have given ambient temperature as sea level, then only you have to take this parameter. Then you have learned this propulsive, thermal, and this. Okay, now take down this problem as your assignment work. So this is again a problem based on turbojet, the same fashion that we have done, like finding out all the parameters. So the same thing you have to do over here. Okay, now very importantly, they have mentioned all the processors assumed to be ideal and no pressure is lost either in the combustion or in cooperative afterburner. So here what you're doing, there is no pressure loss is handling. So if there is no pressure loss, as we have discussed before, okay, so refer the previous video and act accordingly. So note down this parameter, and this is just like your assignment work. Now let's solve this problem. Okay, this is another turbofan problem. This is another turbofan. So in this problem we will only focus on how to find out thrust force. Okay, let's omit this propulsive efficiency. We'll only focus on thrust force, how to find out. Now first we'll read what are the given data. A turbofan engine is powering a aircraft flying at Mach number 0.9 at an altitude of 33,000 feet, where ambient temperature and pressure is given. The engine bypass ratio is 3 and hot air passing through the engine core is so and so mass flow rate. Preliminary analysis result shows that fuel to air ratio is, they have given MF ratio, that is M.015. F equals to 0.015. They have given see here they have given PEC. Now what can you identify from this thing? PEC and PEH, UEC, UEH. What does that mean?
Oh,
Already I have discussed that some book or they have explained as a inside one, the core one as a hot section. So that means these are the parameter for the hot section. Okay. And the bypass part is a secondary, or they can call as a cold section. So this is a part they have given for the cold section. Here very one more thing to notice, they have given pressure at those points, the exit point of a hot section and the exit point of a cold section. They have given the pressure, they have given the velocity, they have given the area, and they ask a thrust force. So what is the basic formula of the thrust force? Basic formula, the momentum thrust and the pressure thrust. So here we can split this momentum thrust and pressure thrust both for the fan as well as the core, or we can say both for the hot section as well as for the cold section. Can you follow? Now here again they have provided here, that is what is the ambient pressure, that is PA value is known to you. So to find out this pressure thrust for both fan and core, it is not a very difficult task. So first we will write down the general formula for the thrust, and then we will see what are the given data we have. Now write down the formula along with me. Now what is the basic thrust formula for the turbofan? The thrust, fan thrust plus core thrust. Now each of these thrusts are again subdivided into two ways. One is a momentum thrust, one is a pressure thrust. Momentum thrust and the pressure thrust. So for the fan, what is a momentum thrust then? So m dot of fan, or I can say for the cold section, okay, for the, as fan is a cold section, VE of cold minus VI is for the, this is for the momentum thrust for the fan thrust alone. Okay. Now what I can write for the pressure thrust? Similarly, I don't have to make much complication. Pressure thrust, so PE of cold minus P of ambient into PE of cold, that is for the cold section what is the exit. So this is the entire part is for the thrust of my fan thrust. Now I will consider the core thrust. Now what is a core thrust? Subdivided into the momentum thrust and the pressure thrust. Why I am splitting this, I will come to that point as well. Now first you remember what is a momentum thrust. So we know in general, that is m dot of as we are discussing about in hot, so we will write hot, okay, 1 plus of F of VE of hot minus VI. So this is the formula I can write here for this is the value for the momentum thrust. Now what is for the pressure thrust? Pressure is the difference of pressure in the core. That is a pressure exit at the core minus at the ambient into VE of core. I mean core in the sense hot. Here we are discussing the hot. So we'll write hot here. Any confusion writing this formula? And in this sequence, first of all, if you write in this sequence, it is going to be very easy for you to remember. As here we are discussing about in hot, so I will write here hot itself. Now, there is another reason. Sometimes they will give you some general data in the question and they will ask you find out the momentum fan thrust. So you just need to find the value for this alone and give the answer. Or they can ask you some specific value. So they can ask you the pressure thrust of a fan, or pressure thrust of a core of a turbofan, okay, core region. So they can specify you, so you should able to identify which are the forces that we are using here. Now this is done. Now these are the requirements to find out the entire thrust. Now we will look what is the given data. Okay, any doubt over here? Any doubt?
No, ma'am, it is clear.
Right. Now we'll see what are the requirements. Now again you notice here they have given and Mach number, and this is one of the train in the gate. So they will not give you the data very in a direct form. So as in the beginner, what they will think that what is the relation with the Mach number with the thrust. So straight away they will think in that approach. So but you have to think in other way around, that Mach number has a relation with Vi by A, and which is nothing but root over of gamma RT. Okay, so this is the, I am showing you the connectivity. So this is likewise I will show you one more connectivity at the end. So what kind of connectivity you can get, which kind of connectivity they are looking for. Now Vi by root over gamma RT. Now obviously you will use this ambient pressure temperature over here. Gamma value will take 1.4, R we will take as 287, and you know the Mach number, you can find Vi. Vi is known, that is one of the common parameter. Now we, apart from this parameters, so pressure thrust part is done for both the side, U part is done. Now we have to take care of the mass flow rate. Now you see here what are the requirements. So this value is known, this we can find out, this is value is given, this value is given, this value is given, this is a we can found, this value is given. Now what is the main parameter we have to found? Mass flow rate of the cold section, mass flow rate of the hot section, F value. Now F value is also provided in the question. The only thing we need to know what is the mass flow rate of the cold and hot. Let's see whether they have given or not. So hot section they have given what is a mass flow rate. Hot section they have given, okay, mass flow rate, that means for the core part they have given what is a mass flow rate. Now we need to find for the bypass ratio is given. Now what is bypass ratio? Mass flow rate of the cold section to the mass flow rate of the hot section, isn't it? Or if I see other side, mass flow rate of the secondary to the mass flow rate of the core, right? This is the actual formula. So this is given, bypass ratio is given, hot value is given, hot mass flow rate value is given. So obviously you can find mass flow rate of the cold as well. So once you can find out the mass flow rate of the cold, and you can find the other side.
Ma'am, mass flow rate of cold is equal to 68.1 kg per second.
68.1
1.
68.1 kg per second. Okay. What is Vi?
$269.15.
Okay. Vi is known. So you just need to substitute in the formula. Anything else left out? I hope no. Now m dot of hot already provided in the question, and F is given, m dot of cold is known. Right now substitute and give me the answer in 2 decimal place, and unit I need in terms of kilonewton. I need the unit in terms of kilonewton and 2 decimal place. Tell me the answer.
Nineteen point 15 kilonewton.
Okay. I hope all are getting this answer. All of you kindly confirm. Are you getting the same answer? All right.
19.25 aircraft.
Okay. So I hope you got the idea what type of, if there is a question from turbofan or turbojet, you can answer for it. Can you? Are you confident enough? Right? You can do it. Now we will discuss that if they ask that how we can connect now application based question. Now let's they have given a question something like an aircraft. Okay, they have given some data, an aircraft, it's flying with an something L by D ratio of maybe 15. Okay, and flying, so to flying at some altitude, okay, maybe 35,000 feet, flying at 30,000 feet, and whose L by D ratio is this much. And when this aircraft is flying, whose air to fuel ratio is 0.015, and calorific value is around 44 megajoule per kg. Okay, now they have given the efficiency of the entire aircraft, or the overall efficiency of the aircraft is around 50%, and at certain point, okay, so what is the range of aircraft that an aircraft can travel if the complete mission process, okay, mission starting to end point, that is a aircraft, the end to the aircraft at the cruise, they have given some value, maybe 0.7. Okay. Now how much if the end point weight fraction is given, and they have given this efficiency, they have given L by D, they have given fuel ratio, they have given the CV. In that case, how can you find out the range? How can you find out the range? Yes? How can you? Any clue? How can you relate with the range? Okay, let's take in this way. So if your fuel burn is more, so how it is going to impact on an aircraft? How it is going to impact on your aircraft?
Reduce, ma'am.
It will reduce. That means
Reduce.
the range will reduce. Suppose you have taken 10 liters, okay, 10 liters of your aviation fuel. You have considered 10 liters of aviation fuel, okay, to fly at certain distance. And if your consumption of fuel is more, obviously you cannot travel that much distance. Suppose you plan for 10,000 kilometer, you will end up in 8,000 kilometer, isn't it? It will reduce it. So what as an engineer has to do? What are the possible modifications will you make to improve the fuel efficiency? To improve the fuel efficiency, what are the possible thing you will make? So which component you will give the more focus? So which component you will try to improve the efficiency? Which component you will try to improve the efficiency?
specific fuel consumption.
I'm asking about which component, like engine component. Which engine component you will give the more focus?
Turbine.
Okay, any other answer?
Compressor, ma'am.
We have compressor. Okay, any other?
Combustion chamber, because heat input.
Very good. See, this is a very simple question, isn't it? So when I said about the few simple thing, you got confused, and this is what the GATE exam question papers looks like. The questions are hidden behind it. So from where we inject the fuel? Why we is to? Because fuel efficiency is, so we have to give more focus on the combustion chamber only. So we have to take care of the combustion chamber. Maybe we have to implement baffle, so how the better turbulency will takes place, so we can get a complete combustion. So the incomplete combustion, okay, that as we are increasing the SFC or the fuel burn, okay, increases because of the problem of the combustion chamber. No doubt all are interconnected, no doubt in it, okay, but when we talk about this, the more focus is on the combustion chamber.
Ma'am, even it is possible that compression is not good because of that
That's why
also.
I said that. Yes, that's why I said they are also interconnected, okay. They're interconnected, but if the question is like specifically that how we can improve the fuel, like how we can this something relevant to SFC, then you have to target to the combustion chamber. The ultimate matter is a combustion chamber when it talks to about this, okay. But no doubt, as you said, and here you see also I mentioned they are interconnected. Because if the pressurization of the air is not done properly before feeding inside the combustion chamber, again it is going to create a problem, right? And if the diffuser is unable to suck the air properly, if the flow pattern and there is a huge amount of losses, again it is somehow going to affect the combustion chamber, right? So these the things you have to make a clarity on it, okay. So this is a general layout, okay. So we will solve this problem when we are in the flight mechanics. We will see some problem how we can relate this propulsion and your flight mechanics, okay. So that's all for today. If you